Hey everyone, so I'll use this video as an opportunity to review price elasticity of demand, which we know as PED. So the concept of elasticity in general measures how sensitive or responsive one variable is to changes in another variable. So when we say price elasticity of demand, this is a measure of the responsiveness of quantity demanded to changes in price. We look at how quantity demanded changes whenever there's a change in price. Now, if you'll remember, the law of demand states that ceteris paribus, as price rises, quantity demanded will fall, and ceteris paribus, the opposite is true. As price falls, quantity demanded will rise. Now, PED, the price elasticity of demand, measures by how much. So, since the law of demand says as price rises, quantity demanded will fall, price elasticity of demand tells us by how much will quantity demanded fall if, say, price rises by 10%. Okay, so the law of demand tells us the direction at which quantity demanded will change when price changes. Price elasticity of demand measures by how much, or the sensitivity or responsiveness of quantity demanded to changes in price. So how do we calculate PED? Well, basically, it's a very simple formula. We look at the percentage change in quantity demanded divided by the percentage change in price. So you need a new quantity demanded minus an old quantity demanded. So Q2 minus Q1 divided by the old quantity demanded, Q1 times 100. All of this divided by, so this is between brackets, between parentheses, and then all of this divided by P2 minus P1, so the new price minus the old price divided by P1, the old price times 100. This is the formula for calculating PED. So the two very general cases, if percentage change in quantity demanded is greater than the percentage change in price, we say that demand is relatively price elastic. And when you calculate it, the absolute value of PED, I'm talking about the absolute value, so ignore the negative sign, will be greater than 1. The curve will look relatively flat, like this diagram here where I'm pointing with the arrow. Okay, you will have a relatively flat curve. As you can see, when price falls from P1 to P2, which looks like a 50% fall in price, for example, the increase in quantity is much larger than 50% from Q1 to Q2. Okay, and the opposite is true. If the percentage change in quantity demanded is lower than the percentage change in price, we say that demand is relatively price inelastic, and the absolute value of PED when you calculate it will turn out to be less than 1. This leads to a relatively steep demand curve that looks like this one over here. As you can see, the same fall in price from P1 to P2, which is about a 50% fall, leads to a much smaller, in terms of proportionate, change in quantity demanded from Q1 to Q2. These are the two general cases. Demand is either price elastic or price inelastic. However, there are also some hypothetical cases that we also need to look at. So if the percentage change in quantity demanded is 0, PED, when you do the calculation, will turn out to be 0. In this case, we say that demand is perfectly inelastic. Quantity demanded is fixed. It doesn't respond at all to changes in price. So as you can see here, when price fell from P1 to P2, it's the same quantity demanded. The demand curve is a vertical demand curve when demand is perfectly inelastic. The opposite hypothetical scenario occurs when the percentage change in price is 0. If you divide the percentage change in quantity by 0, anything divided by 0 gives us a number that is infinitely large. So PED will be equal to infinity. Here we say demand is perfectly elastic, and this is represented by a horizontal demand curve where you have a fixed price, P1, regardless of whatever quantity demanded. The price just doesn't change. The price is not, the price is fixed. The last case is, what if the percentage change in price is equal to the percentage change in quantity? If you divide them, this will give you an absolute value of PED. So again, absolute value will be equal to 1. Here we say demand is unit elastic. There is unitary elasticity. This results in a rectangular hyperbola. okay? Where, as you can see here, the percentage change in price, say for example, price fell by 50%, has led to the same percentage rise in quantity. Okay, so the percentage change in price will always equal to the percentage change in quantity, and this leads to a demand curve that looks more like a curve. It's a rectangular hyperbola like this. Now, another very important concept that's relevant to PED is the concept of total revenue. Total revenue is the total amount of money a firm earns from selling its output. How do we calculate total revenue? Well, it's equal to TR is equal to P times Q. Now, total revenue becomes very relevant when we look at elasticity, because if demand is elastic, okay, a small fall in price will lead to a much larger rise in quantity demanded. So you can see here, there's a small arrow, the small fall in price, and a much larger rise in quantity demanded. Therefore, total revenue will rise. And the opposite is true. A small rise in price will lead to a very large fall in quantity demanded. So total revenue will fall. So when demand is elastic, it's actually better to lower the price if the goal of the firm is to increase total revenue. Okay, let's have a look at the opposite scenario when demand is inelastic. When demand is inelastic, a rise in price will lead to a much smaller fall in quantity demanded. So total revenue will actually rise. And the opposite is true. A fall in price will lead to a much smaller rise in quantity demanded. So total revenue will actually fall. So if demand is inelastic, it's better for the firm to actually raise its price if it wants to increase total revenue. So if demand is elastic, it's better to lower the price if the goal is to increase total revenue. If demand is inelastic, it's better for the firm to raise the price if it wants to increase total revenue. This can also be represented diagrammatically. As you can see here, when demand is elastic, a fall in price will increase total revenue. You can see here price fell from P1 to P2, but it led to a huge increase in quantity from Q1 to Q2. All right. The red rectangle, TR1, is the total revenue, the original total revenue. TR2, the blue rectangle here, is the new total revenue after lowering the price. You can see that TR2 is much larger than TR1. Okay, so lowering the price to increase total revenue is a good decision in this case. When demand is inelastic, on the other hand, a fall in price will actually decrease total revenue. As you can see here, the same fall in price from P1 to P2 led to a very small increase in quantity from Q1 to Q2. So the red rectangle, which is TR1, the total revenue before the fall in price, is actually bigger than the total revenue after the fall in price. TR1 is bigger than TR2. So here, in this case, lowering price to increase total revenue is a bad decision. This firm should have actually raised the price because the demand for its product is inelastic. So knowledge of price elasticity of demand helps firms make their pricing decisions and whether or not they should raise or lower the price in order to increase total revenue. So what determines PED? What actually determines whether the demand for a product will be price elastic or price inelastic? Well, there are four determinants. Okay, the first one is the number and closeness of substitutes. The second one is the degree of necessity. The third one is the proportion of income spent, and the fourth one is time. In the next few slides, I'll explain each of them. So let's start with the number and closeness of substitutes. Basically, if the product has lots of close substitutes, demand is likely to be more elastic. If the product has few or no close substitutes, so it's a very unique product that has very little or no substitutes, demand is likely to be more inelastic. The second determinant is the degree of necessity. If the product is considered by the consumer, now this depends on the consumer and it's different from one consumer to the other. If the product is considered a necessity or it's addictive, because again, if a consumer is addicted, it'll be considered a necessity for them, their demand is likely to be more inelastic. But if the product is considered a luxury, and similarly, if it's non-addictive, demand is likely to be more elastic. So necessities tend to have more inelastic demand. Luxuries tend to have more elastic demand. The third determinant is the proportion of income spent. If the product is relatively expensive, again, that depends on the consumer. If the consumer's income is very low and the product is relatively expensive, it takes up a big proportion of their income. This consumer's demand is likely to be more elastic. If the product is relatively cheap and takes a very small part of the consumer's income, very small proportion of the consumer income, demand is likely to be more inelastic. Its demand is likely to be less responsive to changes in price if the product is cheap. And the last determinant is time. Basically, in the short run, consumers take time to adjust their spending habits. So in the short run, because consumers, their habits are likely to continue for a period of time, demand is very inelastic in the short run. But in the long run, as consumers search for cheaper alternatives and alter their spending habits, in the long run, demand generally becomes more elastic. So we talked about how PED is useful for firms and it helps them with their pricing decisions. PED is also useful for government decision making. PED, knowledge of price elasticity of demand, helps governments determine which products to tax. Whenever a government imposes a tax on a product, this tax will discourage consumption and therefore it will lower production and create unemployment. But at the same time, it will raise government revenue. So you can see that taxing a product leads to a little bit of unemployment, but also raises revenue for the government. For this reason, governments prefer to tax products with low PED, with very price inelastic demand, products where the quantity demanded isn't that sensitive to changes in price. A very good example is cigarettes. Cigarettes are addictive, right? Consumers who are heavy smokers consider them necessities because of their addictive nature. Cigarettes have low PED, they have very inelastic demand. So if the government taxes cigarettes, for example, it will discourage consumption by a small amount, and therefore it won't create too much unemployment. At the same time, it guarantees that the government will raise tax revenue because consumers are somewhat addicted and the majority of them will probably continue smoking. So governments prefer to tax products with low price elasticity of demand because when you tax a product with low price elasticity of demand, you're not discouraging consumption too much, you're not creating too much unemployment, and at the same time, you're guaranteeing a stable source of government tax revenue. So this was a review of price elasticity of demand. Please contact me if you have any questions.